Hello everyone and welcome to a discussion on flow nets near aquifer boundaries under this groundwater engineering course. So, in the previous discussion we have already discussed the two types of aquifer boundaries. Now, what would be the situation if we see the flow nets along these boundaries? So, what are the variations which we are going to encounter about the aquifer boundaries? So, we have also thought about the imaginary wells or image well theory, but here what the scenario which we are having is two wells. One is the discharging well from where the water is being taken out, and another one is the recharging well where we are recharging, and this boundary is assumed here like this. So, in the previous discussion we had a inverted cone of depression, that is cone of buildup. So, similar thing is here, that recharging will develop a cone of buildup and this discharging well will develop a cone of depression. So, in terms of flow nets around the pumping well which is adjacent to aquifer boundaries are useful in solution of hydrological problems. And such flow nets are also useful which will aid in visualizing the hydraulic conditions in the vicinity of any boundary, these two types of boundaries which we have discussed. And several different methods can be employed to draw flow nets in such situations. So, the aerial flow nets, one type of flow nets, that is aerial flow nets, can be constructed by trail and adjustment on water level contour maps. As we have seen in these flow nets, that we are having the flow lines or the contours having different values or different depths, and there are flow lines which are indicating whether it is a recharge or discharge. Like here also you can see that these recharge lines are going from away from well, and whereas these flow lines are coming towards the well, because the water will rush towards the well. So, they will be converging towards the well in case of a discharge well, and these contours are representing of course these equal levels of water level, equal heights of water level. So, when we look vertical flow nets, that can be so one is the aerial flow nets, another type of flow nets is vertical flow nets, can also be constructed along aquifer cross sections when water level data are available for wells at different depths along the line of section. So, by these two types of flow nets we can have a plan view as well as section view. Plan view we can have like this one through the aerial flow nets, or through the vertical flow nets we can have a section also, which will allow us to understand not only the aquifer boundaries, but behavior of an aquifer in case of recharge or discharge. And the second method which we have just discussed, the vertical one, for drawing flow nets utilizing information about the hydraulic characteristics of an aquifer and about the position and nature of the aquifer boundaries. And the third method for drawing flow nets which utilizes the mathematical formulae by which we can also. So, three methods: aerial, vertical, and then third one is the mathematical method. So, there were hydrologist Jacobs who drives a formula for flow net of a well in a uniform fluid, and flow nets for the two adjacent wells, and of course, one is discharging, another one is recharging. So, these equipotential lines, or in simple terms we say contour lines representing the water level, form a group of circles around each well, as you can also see here, that a group of circles are there, and the distance between these contours equipotential line increases when you go away from the well, whether it is a discharging well or recharging well. Further, then this radii of these circles will increase from the center, and these moves progressively further away from the boundary, and this is what we see. So, Jacob demonstrated that a given potential surface we can take like this, that x minus x1 square plus y square upon x plus x1 square plus y square, and that is what we get the equation 1 here in this discussion is that is equal to C. Now, this radius of an equipotential line is that r equal to 2x1 under root C divided by 1 minus C. So, that becomes our second equation. Now, at the center of the circle, so that we get the x1 1 plus C and divided by 1 minus C. So, this becomes our third equation. Now, where we know that the x1 is the distance, as you can see here also, x1 is the distance from the boundary to either of the real or image well. So, this in earlier figures also we have taken this that this is the distance between the imaginary well or real well, discharge well or recharge well. So, any potential equipotential circle which are shown here or contours can be drawn if the position of the center of the circle and its radius are known or determined. So, here the x minus x1 square plus y square divided by x plus x1 square plus y square c, and then in this equation if y is assumed to be 0, then this equation 1 is solved progressively for larger values of x and values of constant c can be readily determined. So, this equation then we can change this one to that we can get the r for r and x as well. So, substitution of the values of c and x1 in equation 2 and 3 will yield the radius and position of the center of each equipotential line respectively, and these two will give us the positions. So, with this what we get that when we were discussing imaginary well or real well, now in this we are considering recharge well and discharge well, and of course, the boundary is also there. So, with these three equations we can solve this, we can develop the flow nets of all three types, that aerial one, vertical one and mathematical one through these three equations given by the Jacob. So, with this I end this discussion. Thank you very much.